In this video we're going to be looking at the various math nodes available in the Unreal Material Editor and give a few examples of how they might be used within our shaders. The add expression takes two inputs, adds them together, and outputs the result. If you pass values with multiple channels, each channel is added separately. For example, if you pass RGB color values to each input, the R channel of the first input is added to the R channel of the second input and the result is stored in the R channel of the output. The G channel of the first input is added to the G channel of the second input and the result is stored in the G channel of the output, and so on. Both inputs must have the same number of values, unless one of the values is a single constant value. In that case, each channel of the multi-channeled input is added to the single float value, and the result is stored in a separate channel of the output value. Add is often used to brighten, darken colors or to offset UV texture coordinates. The subtract node takes in two inputs, subtracts the second input from the first, and outputs the difference. If you pass values with multiple channels, each channel is subtracted separately. For example, if you pass RGB color values to each input, the R channel of the second input is subtracted from the R channel of the first input and the result is stored in the R channel of the output. The G channel of the second input is subtracted from the G channel of the first input and the result is stored in the G channel of the output, and so on. Both inputs must have the same number of values, unless one of the values is a single constant value. In that case, each channel of the multi-channel input has the constant value subtracted from it, and the result stored in a separate channel of the output value. The multiply expression takes two inputs, multiplies them together, and outputs the result. When you pass color values as input, the results are similar to the results of the multiply layer blending mode in Photoshop. If you pass values with multiple channels, each channel is multiplied separately. The divide expression takes two inputs, divides the first input by the second, and outputs the result. If you pass values with multiple channels, each channel is divided separately. The OneMinus expression takes an input value, x, and outputs, 1 minus x. This operation is performed per channel. Examples: 1 minus of 0.4 is 0.6, 1 minus of 0.2, 0.5, 1.0 is 0.8, 0.5, 0.0, 1 minus of 0.0 minus 0.4, 1.6 is 1.0, 1.4 minus 0.6. When the input colors are in the range 0, 1, 1 minus has the same effect as what is commonly called invert, that is, 1 minus returns the complementary color that when added to the input will produce white. The power expression takes two inputs, a base value, base, and an exponent, exp. It raises the base value to the power of the exponent and outputs the result. In other words, it returns base multiplied by itself expressed times. Example usage: if the colors you pass to power are in 0, 1, power can behave as a sort of contrast adjustment, where very bright values are dimmed slightly, but darker values are decreased drastically. ABS is an abbreviation for the mathematical term, absolute value. The ABS expression outputs the absolute, or unsigned, value of the input it receives. Essentially, this means it turns negative numbers into positive numbers by dropping the minus sign, while positive numbers and 0 remain unchanged. The absolute of a value just means to take the value and make it positive, ignoring any negatives. I.e. ABS, minus 4, equals 4. This is occasionally useful when creating masks using complex math or for creating a bouncing motion from a sine wave. Examples: ABS of minus 0.7 is 0.7, ABS of minus 1.0 is 1.0, ABS of 1.0 is also 1.0. The clamp expression takes in values and constrains them to a specified range, defined by a minimum and maximum value. A minimum value of 0.0 and maximum value of 0.5 means that the resulting values will never be less than 0.0 and never greater than 0.5. Now check the properties. Clamp mode selects the type of clamp to be used. Min default takes in the value to use as the minimum when clamping, only used when the min input is unused. And max default takes in the value to use as the maximum when clamping, only used when the max input is unused. Now understand the inputs. Min takes in the value to use as the minimum when clamping, and max takes in the value to use as the maximum when clamping. Examples: clamping an input range of 0.0 to 1.0, 0.3 with min 0.0 and max 1.0 yields 0.3. Clamping 1.3 with min 0.0 and max 1.0 yields 1.0. The component mask expression allows you to select a specific subset of channels, R, G, B, and or A, from the input to pass through to the output. Attempting to pass a channel through that does not exist in the input will cause an error, unless the input is a single constant value. In that case, the single value is passed through to each channel. The current channel selected to be passed through are displayed in the title bar of the expression. Examples: component mask with an input of 0.2, 0.4, 1.0, and the G channel will produce an output of 0.4, which appears as a 40% bright grayscale value when used as a color vector. Ma and min, two comparison nodes which return the maximum or minimum of the two inputs per pixel. Useful for creating strange masks, such as seen here, or for creating pseudo-random motion. For example, on a graphic equalizer shader you could take the max of 2 out-of-phase sine waves to create semi-realistic pseudo-random movement. The Ceil expression takes in values, rounds them up to the next integer, and outputs the result. Examples: Ceil of 0.2 is 1.0. Ceil of 0.2, 1.6, is 1.0, 2.0. The floor expression takes in values, rounds them down to the previous integer, and outputs the result. Examples: floor of 0.2 is 0.0. Floor of 0.2, 1.6, is 0.0, 1.0. The Frac expression takes in values and outputs the fractional portion of those values. In other words, for an input value, x, the result is x minus floor of x. The output value will range from 0 to 1, inclusive on the low end, but not the high end. Examples: Frac of 0.2 is 0.2. Frac of minus 0.2 is 0.8. Frac of 0.0, 1.6, 1.0 is 0.0, 0.6, 0.0. In this example, the Frac node is converting time into a series of repeating 0 to 1 progressions, causing the color to fade, via the lerp, from green to red, then snap back to green, repeating indefinitely. These three nodes are similar. Ceil or ceiling takes an input and returns the next integer rounding up. Floor does the same but rounding down, and Frac or fraction just returns the floating point part of the value. Note the black in the floor example and the white in the Ceil, due to rounding down and up. Frac is the most useful here, generally returning repeating values from something like time or sine, but floor and Ceil have their uses too. The if expression compares two inputs and then passes through one of three other input values based on the result of the comparison. Both compared inputs must be single float values. Let's understand the description of each input. Input A takes in a single float value. Input B takes in a single float value. Inputs A greater than B takes in the values to output. If the value of A is greater than the value of B, inputs A equals B takes in the values to output. If the value of A is equal to the value of B and inputs A B, A is greater than B, or if A B if this pin is unconnected. In this example, the if expression takes in a height map, and outputs either red or green, based on whether the height falls, under or over a value of 0.45. It compares two input values A and B, and returns a different input value. If A is greater than B or if A is smaller than B, there is also a special case for A equals B, which is basically never really needed in shader writing. It defaults to A equals greater than B if this pin is unconnected. The LinearInterpolate expression blends between two input values based on a third input value used as a mask. This can be thought of as a mask to define transitions between two textures, like a layer mask in Photoshop. The intensity of the mask alpha determines the ratio of color to take from the two input values. If alpha is 0.0, the first input is used. If alpha is 1.0, the second input is used. If alpha is between 0.0 and 1.0, the output is a blend between the two inputs. Keep in mind that the blend happens per channel. So, if alpha is an RGB color, alpha's red channel value defines the blend between A and B's red channels independently of alpha's green channel, which defines the blend between A and B's green channels. Now we're talking. This node just takes two inputs and blends between them, based on an input value, 0 to 1. Values of 0 will result in input A and values of 1 input B. This is a real workhorse of a node in shader writing, being used all the time for any manner of things. The AppendVector expression allows you to combine channels together to create a vector with more channels than the original. For example, you can take two individual constant values and append them to make a two-channel constant 2-vector value. This can be useful for reordering the channels within a single texture or for combining multiple grayscale textures into one RGB color texture. This node is basically the opposite to the mask node we covered earlier. It takes two inputs and outputs them combined, such as in the example where we're combining three scalar values into a vector 3 or color. Another indispensable node when working with scalars and vectors. The sine expression outputs the value of a sine wave over the input range of 0, 1, and the output range of -1, 1, both repeating. The difference between this and the output of the cosine expression is the output waveform is offset by 1/4 of the period. Most commonly, this is used to output a continuous oscillating waveform by connecting a time expression to its input, but it can also be used to create ripples in world space or screen space, or any other application where a continuous, smooth cycle is needed. Now let's see what is input period. Specifies the period of the resultant wave. In other words, this is how long one full oscillation takes to occur, or the time between each successive crest or each successive trough in the waveform. For example, in the image above, the period is 1 second. The CrossProduct expression computes the cross-product of two 3-channel vector value inputs and outputs the resulting 3-channel vector value. Given two vectors in space, the cross-product is a vector that is perpendicular to both of the inputs. The max expression takes in two inputs and outputs the higher of the two. When you use this node with color inputs, the result is similar to the lighten layer blending mode in Photoshop. In the example above, A is 0, and B is 1, therefore, 1 inch, white, is the resulting base color. The min expression takes in two inputs and outputs the lower of the two. When you use this node with color inputs, the result is similar to using the darken layer blending mode in Photoshop in the example above. A is 0, and B is 1, therefore, 0 inches, black, is the resulting base color. The normalize expression calculates and outputs the normalized value of its input. Normalized vectors, also called unit vectors, have an overall length of 1.0. This means each component of the input is divided by the total magnitude, length, of the vector. Examples: passing either 0, 2, 0, or 0, 0.2, 0 through normalize will output 0, 1, 0. Passing 0, 1, -1 through normalize will output 0, 0.707, -0.707. The only special case is an all-zero vector, which will be unchanged. The round expression rounds the input value to the nearest whole number. If the fractional part of the input value is 0.5 or greater, then the output value is rounded up. Otherwise, the output value is rounded down. Examples: a value of 1.1 will be rounded down to a value of 1. A value of 1.4 will be rounded down to a value of 1. A value of 1.5 will be rounded up to a value of 2. A value of 1.85 will be rounded up to a value of 2. Hope from this video, you will start to move into building in more advanced mechanics, in an easy-to-follow step-by-step approach, which will allow you to play around and build your own content, to eventually build your own game. Thanks a lot, see you in the next video.